In this video, we'll implement a custom RAYCAST car physics from scratch. RAYCAST cars avoid the complexity of wheel colliders, giving you lighter, fully controllable physics. They're perfect for arcade-style gameplay. So let's begin. Start with a box rigid body. Notice it just falls to the ground. Let's add suspension to properly ground the car. Define the wheel positions on the four corners. In a RAYCAST car, the wheels aren't physical. Think of this point as the spring attachment, since we're focusing on suspension. For each wheel, cast a RAYCAST downward to find the ground. Use the hit info to calculate the spring force. The spring force pushes the car up, making it hover above the ground on its imaginary wheels. The formula consists of a constant times the displacement from rest length. The rest length is simply the length the spring likes to maintain at equilibrium. The more the spring is compressed, the larger the displacement, and the stronger the push force. Let's see it in action. Notice the car keeps bouncing forever. That's because we're missing a key part of the spring damper. Let's watch the spring's relative velocity. We'll use it to calculate the damper force. The damper force resists the spring's motion. Think of it like a piston moving through thick fluid. It slows the motion down. The formula consists of a negative constant times the spring's relative velocity. Add the spring and damper forces together. Now the spring stabilizes as expected. With the suspension in place and the car grounded, let's make it move. To make the car accelerate and brake, apply forces along the wheel's forward direction. Apply these forces slightly below the center of mass. This will result in a tilt effect. Notice that if we turn the wheels while accelerating, the car spins uncontrollably. That's because we haven't added tire grip yet, so it can't steer properly. Let's implement it. Take the wheel's current velocity. This velocity can be broken down into longitudinal and lateral components using the dot product. The longitudinal velocity is along the wheel's forward direction. This is the direction the wheel wants to roll. The lateral velocity is along the wheel's right direction. This is the direction the wheel doesn't want to slide. To make the car steer, we apply an opposing force proportional to this lateral velocity, resisting the slide. This simulates tire grip. Now the car steers as expected. Set a high grip factor to make the car turn very responsively. Or set a low grip factor to make it drift. Like with the acceleration forces, apply these grip forces slightly below the center of mass to add a lean effect when turning. The physics are done. Optionally, you can swap the visuals. Replace the cube with a car model. Use the suspension and steering values to update the visual wheels. The car model can look like anything, since physics and visuals are completely separated. And that's it. We now have a fully working RAYCAST car with the core physics in place. If you want a full, production-ready implementation, you can find the link in the description. Thanks for watching, and happy coding!